we see that we have introduced a time origin 0 and a final time, capital T, which in our example of particle falling from A to C via the holes in B correspond to having the particle in A at t equals 0 and in C at t equal capital T. So that defines our initial and final event, which are connected by a path. In the case of a particle falling through the holes, this is clearly a problem in 2 dimensions. So if now we consider a simpler case of a one-dimensional problems, we can easily define and represent events and the path as. But we have just learned that in quantum mechanics a particle can be at different positions at the same time. So there is no reason to consider only one path. In fact, we should consider all possible paths which. Moreover, we have seen that only the phase matters. So in fact, all these paths contribute to the amplitude of probability equally. So the amplitude of probability for the particle to go from x0 at t equals 0 to x1 at t equal capital T is the sum over all the possible paths of exponential I times the action divided by h bar, and that's the action associated for each individual path. This equation could be considered as a fundamental starting point of quantum mechanics. From this you can derive probably all theorems and properties of quantum mechanics which are verified on every day in experiments. This is also a formulation of quantum mechanics which allows to make connections with classical physics, and in particular we will show that from this equation we can derive the stationary action principle. In other words, it's not a principle anymore, it becomes a theorem, and the principle is the equation you are looking at right now.